Hello and welcome back. If you've been following along, last video we created a player that was able to move around, and we used this move command and the act method so that when the action happens in your code, when you push run, they will move, and you're able to turn them with the right key and the left key. You can see the right key turns right, turns 2 degrees. Left key turns 2 degrees. If you hold it down 60 times per second, this code runs over and over and over again. So today we're going to learn how to create a separate method. This is to not only help organize your code, but also it makes everything a little bit more efficient in the speed at which you're able to create some of the things that you want to do. Also, when you get deeper into programming, this will help make things work a little bit easier, a little bit nicer for you, and you can use these methods in multiple areas, multiple times, and allows you to return different things if you don't just want to do commands. But we're going to start off with just commands. So the fact that we want to access this code method, you have to start with whether you're able to access it, if it's public or private. So we're going to want to be able to access it. So I'm going to start with public. Void means that it's, once again, it's a command. We don't expect the computer to output a number as a possible output. So you could do public int, you could do public boolean, which is a true false, you could do public double, you can do public, you can do quite a few different things with it. And so we are not gonna, it's just gonna be a command, and we're just gonna call it the move around command. And what this is called is camel case. So move is that lowercase m, and the A around is the capital A. This allows you to be able to move around. This code alone, though, doesn't mean anything to the computer. The computer has no idea what move around is. We could make it whatever we wanted, and the computer would just do whatever is directed as long as we put this somewhere else into the act method. This is just storing information right now. So what I'm going to do is I'm going to move this code, cut it, and I'm going to paste it down here. And if you notice these curly brackets, make sure that you get a close look on these curly brackets. So I'm going to go to my options, preferences, and just move up the font size a little bit. These curly brackets are very important. So you are making these curly brackets. These are sometimes called blocks to block off your code. So whenever you start a method, you want to have a curly bracket. Whenever you start a class, this is a player class, this automatically is entered. And then if you start an if statement, you want that curly bracket. Actually, if you only have one line of code, you don't have to have curly brackets in Java because it will read the one line. So if I left it like this, there would be no errors, but it's just good practice to have those, because we're going to have if statements that have a whole bunch of commands to it. If you're running into an enemy, you might want to, or you hit the enemy with your projectile, you might want to destroy the enemy, add score, remove your bullet, and increase your speed or whatever you want to do, or increase your points or something. So you want to make sure that you know how to implement those curly brackets. And notice whenever I type an if statement, so if Greenfoot dot is key down, we're going to use the space bar. Go ahead and do this. This isn't just an example. I add this parenthesis to close off what the text will be, or whatever I'm inputting in the is key down is. And then this parenthesis, if you notice, if I click, it highlights the other parentheses that I'm closing off. So in the if statement, make sure you have the correct number of parentheses. And then I do curly bracket, open curly bracket, enter, and then I leave a space. So I do 2 enters and then a close curly bracket. This allows for my curly brackets to or allows for me to put a command line and leave space. If I just did one space, or maybe had this one after another, I might get confused. You can do that. It'll actually work, but it is a lot easier to see, and it's good practice. I'm a big advocate of good practice to do the things correctly and do 2 enters and leave yourself a space for the command line. It also just looks cleaner and easier to look and read. So if the space key is down, I want to give myself a boost. Okay, and so if I want to give myself a boost, I want to be able to increase my speed. But let's say if I could do it a couple ways. So I could just do move 2, and then it is always going to be moving 2, because that is outside of an if statement. So as long as the move around method is entered into the act method, then this will move 2. It is not yet, but once we do that, it will always do this. And then this is an if statement, so only when the space is down, it'll move 2 more. So it will increase the speed. But I'm going to give you an example of something else here in a second. So now I'm going to show you how that works, and I want to make sure. So if I compile and it's not in the act method, I run it, nothing happens. Okay? If I compile, if I add this, so I'm going to copy this move around, and I'm going to paste it in there, add a semicolon, because that is a command that I want the move around method to run, to happen. So my move around method will be in the act method as well. And so now when I run, it will move. And then if I push space, you can see my speed increases to 4. 2 and 2 is 4. Okay, but let's say I want to do something, a lot different. If I want to change something, if I want my speed to increase more and more and more and more. Okay, so if I go to my player, I'm going to actually increase my turn a little bit so my guy's a little bit more agile. If I want something to change, if you're any good with math or maybe science class, you know that there are things called variables. Now these variables are represented by maybe a letter or a word, and if we want these variables to be able to change, which is usually the point of these variables, you want to be able to store information with these variables or make them change. So we have this 2 and 2. So if I want to create a variable in Greenfoot, and this is a very key component of programming as well, one of the basics, is we are going to need to tell the computer what kind of number we're going to store, what data type. So data type, if you have a pen or paper or something that you write notes on, a data type is a word that is very important to know. It is what type of number or what type of information actually in general is getting stored, not just numbers. But so the type of information we're going to store is a whole number. And it could be positive, it could be negative, because look, we got -4, +4, not that we're using those, but potentially we could. We just want a whole number. So a whole number data type would be an int. An int is short for integer, so an integer number, very simple. So I'm going to call my int, my variable, speed, and I'm going to set it equal to 2, just like what we had. So this is outside of the act method, but it's inside of this class, inside of the player class. So whenever we're talking about our player and we put speed, we just put the word speed, it is going to replace it with an integer, and the integer of speed is going to equal 2 to start. Okay, so if I say speed here and speed here, nothing has changed. You can test that if you'd like, but you don't need to as of now. So what we're going to do is instead of doing move speed, I want my speed to increase more and more and more and more. So I am going to go a little crazy, and I'm going to multiply my speed times 2, but I'm actually going to set my speed so it times 2, and then it changes the value of speed from 2 to 4, and then it'll 60 times per second, it'll run through the code, and it'll times 2 again and set speed from 4 to 8, then 8 to 16. And actually, now that I think about that, that'll be too much, so I'm not going to multiply. You're welcome to test that. Actually, why not? Speed equals speed times 2. Now this is a longer way of doing it. I'll show you a shorter way here in a second. Compile. So now when I push space down, my speed, whoa, he's all over the place. Okay, so fast you don't even know. So that's why I realized I'm going to be going way too fast, because if I hold it down, I mean, I'm tapping it, and it's multiplying, and that exponentially increases, and it makes it go crazy. So we can do, instead of speed times 2, let's just do speed plus 2. So speed equals speed plus 2. So this will increase it from 2 to 4, and then speed will equal 4. And then 4 plus 2 is 6. Now speed is 6. And so when we are moving speed, it's just going to move. I'm not commanding any movement here. I'm just changing my value of my variable. Okay, and there's a ton of stuff we can do by doing that. So now it's a little bit more controlled. It's never, well, it takes a while for it to get out of control. So now if we wanted to just to really emphasize these variables, because they're very important, I'm going to set another if statement. Greenfoot dot is key down V, the letter V, since that's nice and close to the space bar, I can just push a V. Open curly bracket, close curly bracket. I'm gonna have speed equals 1. So that'll slow it way down. Okay? So now, if I space, I'm going faster, and then all of a sudden I push V, now it's slow. Faster, then it's slow. Now if I hold them both down, it's whatever I held down last is what'll do it. So you can mess around with that a little bit. But I'm going to show you a different technique now. Instead of, I'm going to take this out, and I'm going to show you a little bit about what we call an if-else or an if-else-if. So if spacebar is down, speed will increase. Else, speed will be 1. So my speed will actually just be 1 here. I set it to 2 at the very beginning, but once we start running it, it's going to be space isn't down, so it's not increasing. So otherwise, now speed is 1. So that has changed over, and it's just held at 1 until the space bar is down. And then so now when I run it, I can hold it down, but if I let go, the second I let go, it'll go back to 1. So that's what an else will do. It's like, okay, spacebar is down, otherwise we're going to be moving to 1. Spacebar is down, increase, 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 faster, 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 and then we're to 1. Okay. There's also an if-else-if. So that would say, and let's go back to that Greenfoot dot is key down V. And so this is different between the V, because this is saying if the spacebar is down, do this. Otherwise, only if V is down, do this. So the difference between this and this is if I have V down and spacebar down, there will be conflicting arguments. But if I check, space will only be the only one that works if space is down. Otherwise, V will work. But if space is down, space is the only one that works. Otherwise, I like to think this else as like an otherwise, or alternatively, if V is down. Okay, so else V. So now, when I hold space down, and V down, it doesn't do anything. But if I let go of space, now I'm back. But if I take out that else, if V is the second thing that gets pushed down, that'll stop it. But if I have that else in there, see, V is down, space only, now V is down, V and space are down, so it doesn't work. Now if I have space and V down, if it's an else if, space and V both down, only the space would work. Because this only goes to this, execute this next level when space isn't down. The main time you're going to use that is if you hit something, you're going to remove it. Otherwise, it's going to keep moving. If you hit a wall, remove it. Otherwise, you're going to check if it hits a player, hits the enemy. If your projectile hits a wall, remove it. Otherwise, if it hits a player, or vice versa. Okay, so now we have learned a little bit about variables, a little bit about data types, and let's add in another character. So we're going to add in the enemy, and enemy, I'm scared of bees. So my enemy is going to be bees, and I'm going to manually put in these bees. So the class name is going to be bee. Is going to be not B. Is that the name of the class or the object that I'm looking at? No, the name of the class is enemy. I can call it B. I can call it whatever I want to call it. Okay? This is just pre-saved as player. So if I call it B, I just need it to be a new instance of the B, which is of class enemy. So it's an instance of enemy is the name of the class. And we're going to add object B at 50, 60. Okay, now I copy this. I'm going to add in a couple of them, a couple more. Now it has a problem. Variable B is already defined. We've already created B, so then it would be confused thinking that it's the same B. We want a different B, so I'm going to go B1, B1, B2, B2. So I'm going to put these at different spots. So I'm going to put it at 100 and 200. Oh, not 2,000. And 600 and 620. So these will be all over the place. Okay. If I want to move them, I could save the world. I'm actually not even sure what would happen. They'd probably rename them and an error would pop up. Yep. So they want to name it enemy 3. Relocate it and call it enemy 3 because that's what they do. So if we want to follow what they do, we need to change these. But we can change the location ourselves. So let's change our Y value to a little bit different, to like 320. Okay, so that'll put 3 right in the middle. Alright, that's fine. Now we're going to go to our enemies, and now our enemies are not going to move like our player. Our player right here. Enemy. Okay, so we're going to have our public void move around, and we're going to move 4, and we are going to do one more little bit of if statement. That's going to say if the X value of the B reaches the edge of the world, which is 800, 792, very, very close here. If it is greater than 799, we're going to flip it back to the other side of the screen. So here it is. If get X, so this gets the X value. The reason we have an open close parentheses is because we have these are called parameters. And the reason you have an open close parentheses right here is because if it gets greater, it needs to have a space holder for the number. So we are asking the computer, please get an X value and locate it. Locate the number that you find right here. Otherwise, it's going to have issues with it. So you want to give it a placeholder. If it's greater than 799, greater than or equal to 799. That's plenty close enough to the edge of the world. We are going to set location, another command that's available in Greenfoot. set location to our current, no, we're going to set our location to 0, which is the left side of the world. And then the Y value is going to stay the same. So if you notice, all these B's have different Y values. This one's up here, Y value. This one's more in the middle, and this one's at the bottom. X axis, Y axis. Okay, and so interestingly enough, in Greenfoot, the 0, 0 is right here, and the max size of the world 800, 600. I think it's 790. Since we start at 0, the 799 is the greatest it can be, and 599 is the greatest it can be for the Y value. So since it starts at 0, 0, there's 800 total. 0 to 799 is 800 total. It doesn't start at 1. So that's why I did greater than or equal to 799. And then the location is back to 0, which is the entire left side. And then we're going to have our Y value just be get Y. We found get X right here. You can find the Y value and air quote, relocate the object to the same Y value. The X will change. It'll go to the edge of the screen and then wrap back to the other side. And I will show you what that looks like. And that's all the code is. It's pretty simple, guys. So if it's running, we need to make sure that this is in the act method. One of the most common mistakes. If your code is perfect, the most common mistake, you'll be like, Mr. Crow, why isn't it working? Why isn't it running? You didn't put it in the act method. I tell my kids over and over, they'll come over and they'll say they've been working on something for 30 minutes. Did you put it in the act method? No. Okay, you need to put it in the act method. I forget it all the time. I just did right there. And then now, notice these B's stay at the same Y value. Okay, but their X value changes. So they go forward, hit the edge of the world, and they get turned back. Now, what if they are turning? So let's have these B's. If Greenfoot dot is key down, left, we're turning -1 and +1 for Y. Copy, don't reinvent the wheel, copy and paste. Right, +1. Now we run, we can turn them. So what are they going to do? Well, their Y value won't change. You notice their Y value won't change when you wrap, right when you wrap. It's still, if I put it right here and right here, they're still wrapping to the same spot on the Y value. Now their X is different. Okay? So now we have objects that are able to move across the screen. They turn a little bit slower. You're able to speed up, use variables. You know if-else-if statements and if-else statements. You've been introduced to if statements. You've been introduced to data types. Been introduced to variables. How to create a method. If, otherwise, or alternatively, if this. Just a if-else statement. All of those things are really important because of exactly how you want your game to work. So keep following along, keep working. We're going to keep moving through this, and I hope you guys see where we're headed. We're going to make these enemies be a little bit more dangerous next time. And we're going to have a you win screen and a way to finish and complete our game. But please join me next time. I hope you enjoyed it. And thanks for watching. Please go ahead and, if you haven't already, I would appreciate you subscribing to the channel, and putting a like is always appreciated, and leaving any comments if you have any questions. So thanks for watching. Until next time.